are going to learn what is valence shell electron pair repulsion theory, VSEPR, and later you will draw the basic molecular shapes that are linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. And lastly, you are going to predict and explain the shapes of the molecule and the bond angles in a given species.
These are the different representations of CCl4 molecule. Can you spot the difference between these two structures? Structure on the left is called Lewis structure, which is drawn in the form of 2D structure, and the structure on the right is called molecular geometry, which is in 3D formula. In molecular geometry, we can identify the bond angle between the bonding. Meanwhile, in Lewis structure, we are unable to identify the bond angle between the bonding. And also, by knowing the geometry of the molecule, we are able to identify some other properties in molecules such as melting point, boiling point, density, solubility, and also types of reactions. So to study whether CCl4 is soluble in water or insoluble, we can get it firstly from the molecular geometry, because from the molecular geometry later on, you can also study the polarity of the molecule.
So in this lecture, we are going to study the molecular geometry or molecular shape for certain molecules from their respective Lewis structure. Valence shell electron repulsion theory or VSEPR. So this model is used to predict the molecular geometry or shapes of molecules. So this theory is based on the concept that electron pairs around a central atom will repel with one another and arrange themselves as far apart as possible in order to minimize the repulsion. So bagaimanakah kita akan dapat molecular geometry untuk sesuatu molekul adalah, according to VSEPR theory, electron pairs around a central atom. So apakah itu electron pairs? Electron pairs terdiri daripada bonding pair electron and lone pair electron pada sesuatu central atom. Okay, so the existence of these electron pairs will repel with one another, akan menolak di antara satu sama lain, and they will arrange themselves as far apart as possible. Okay, dia akan menyusun diri mereka sendiri, okay, menjauhi antara satu sama lain in order to minimize the repulsion, sehinggalah mereka tiba pada satu position di mana repulsion between the electron pairs adalah yang paling minimum. So pada kedudukan di mana repulsion between the electron pairs on central atom itu adalah paling minimum, inilah yang akan memberikan molecular geometry untuk sesuatu molecules. So VSEPR is used to predict shapes or geometry of covalent molecules and polyatomic ions, and it depends on the arrangement of the electron pair on the central atom in order to get the molecular geometry of certain molecules. And in order to find the geometry, we have to consider the sigma bonding only. Here are the important rules in VSEPR. So in discussing this rule, let's take CCl4 and water molecule as the example. So in CCl4, carbon atom will be the central atom dan kita ada sebanyak 4 bonding pairs around this carbon central atom. So macam mana dapat 4? You can look you can count from the bilangan of the covalent bonding over there. Okay, so bila ada 4 covalent bonding, bermaksud kita ada sebanyak 4 bonding pairs around central atom carbon in CCl4. Meanwhile, in water has bonding pairs and also lone pairs electron. Okay, so around oxygen central atom, kita boleh nampak bahawa oxygen ada sebanyak 2 bonding pairs. Okay, 1, 2 dan juga 2 lone pairs electron. Okay, iaitu 1 dan juga 2 di sini. Okay, so according to rules in VSEPR, electron pairs on central atom repel each other. Okay, so electron pair ini merujuk kepada apa? Merujuk kepada bonding pairs and lone pairs of electrons. Okay, so these bonding pairs and lone pairs of electrons arrange themselves to be as far apart as possible. So in the case of CCl4, pada central atom ini hanya ada 4 bonding pair, okay, which means kita ada jenis yang sama, iaitu bonding pair sahaja. So all bonding pairs akan repel with each other equally, okay, with equal strength, sehinggalah tiba pada satu position di mana repulsion between them is the minimum. So at that position, maka kita akan dapat molecular geometry untuk CCl4. Okay, tetapi untuk water, we have two different types of electron pair. Kita ada bonding pair dan juga lone pair. So di sini, according to the third rule in VSEPR, lone pair repels greater. Okay, lone pairs repels greater than the bonding pairs. So di sini kita boleh predict bahawa apabila kita ada lone pair bersama-sama dengan bonding pair di sini, tolakan oleh lone pair ini adalah lebih kuat berbanding tolakan di antara bonding pair sahaja. Okay, so ini akan menyebabkan bond angle di dalam water molecule will be smaller. Okay, akan lebih kecil. So according to VSEPR, this is the order of repulsion strength. So di sini you can see that lone pair repulsion is stronger ataupun greater than the lone pair bonding pair repulsion. Okay, and this is greater than the bonding pair repulsion. So this arrangement tells us that bonding pair repulsion adalah tolakan yang paling lemah. Okay, dan tolakan yang paling kuat adalah di antara lone pair dan lone pair.
So, the difference between the repulsion strength inilah yang akan memberikan molecular geometry untuk sesuatu molekul. To understand the repulsion better, let us see the difference in molecular geometry between CCl4 and water molecules. Carbon is the central atom in CCl4, and as we can see in the structure, carbon has 4 electron pairs, iaitu 4 bonding electrons. And this central atom has bonding pairs electrons only, and there is no presence of lone pairs electrons. Meaning that all these bonding pairs will repel between them equally until they arrive at one position di mana repulsion between them is the minimum. So that position will give the molecular geometry for CCl4, that is tetrahedral. Since there are all bonding pair electrons around the central atom carbon, so the type of the repulsion will be bonding pair repulsion only. So the basic idea to get the molecular geometry for certain molecules adalah bergantung kepada tolakan di antara electron pairs pada central atom di dalam sesuatu molekul. In water molecule, oxygen also has 4 electron pairs on the central atom, but the electron pairs are divided into 2 categories. They are lone pairs electrons and bonding pairs electrons. So, by having lone pairs and bonding pairs electrons, bonding in water molecules will experience 3 types of repulsion forces, iaitu lone pairs repulsion, lone pairs bonding pairs repulsion, and bonding pairs repulsion. According to strength of repulsion by VSEPR, lone pair repulsion exhibit the greatest repulsion force, followed by lone pair bonding pair, and lastly the weakest one adalah bonding pair repulsion. So here, walaupun oksigen mempunyai sebanyak 4 electron pairs sama seperti carbon in CCl4, tetapi with the presence of lone pair pada oksigen ini akan menyebabkan those lone pairs akan repel between them even greater. Dan ini akan menyebabkan dua bonding pairs iaitu OH covalent bonding akan tertolak ke arah dalam dan mendekati di antara satu sama lain. And that will give the different geometry for water molecules that is band shape. In CCl4, each bond angle is 109.5 degree. Sudut di antara setiap ikatan dalam CCl4 adalah 109.5 degree. but the bond angle in water molecules will be even lesser than the CCl4 iaitu 104.5 degree walaupun oksigen mempunyai total electron pair yang sama seperti carbon in CCl4 iaitu 4 electron pairs. This is due to the presence of the lone pairs on oxygen yang mana this lone pairs akan menyebabkan repulsion between them will be even greater. So that repulsion akan menolak bonding ataupun covalent bonding OH ke arah dalam dan mendekati antara satu sama lain, and this will make the bond angle will be lesser than the CCl4.
How to identify molecular geometry? Jom kita tengok steps ni. Firstly, you have to draw Lewis structure for the molecule. Second, count number of bonding pairs and lone pairs on central atom. So in this example of water, oxygen is the central atom, then you have to kira bilangan bonding pairs and lone pairs on the central atom oxygen. In this case, bonding pair ada sebanyak 1, 2 bonding pairs, and lone pairs juga kita ada sebanyak 1, 2. So 2 lone pairs also on this central atom. So after you find out the number of bonding pairs and lone pairs on the central atom, so hence you will get the geometry of the molecule according to VSEPR. And don't forget, for double and triple bond, count sigma bonding only. So for double bond, this is the double bond. Ingat lagi tak? Double bond ini mengandungi 1 pi dan 1 sigma bonding. And for the triple bond, kita ada sebanyak 1 pi, 1 sigma, 1 pi. Okay, bermaksud 2 pi, 1 sigma untuk triple bond. So in order to identify the geometry untuk sesuatu molekul yang mempunyai double bond dan juga triple bond in its Lewis structure, kita hanya perlu consider sigma interaction or sigma bonding sahaja. So follow these steps, and later you will get the molecular geometry for specific molecule. Here are the basic molecular shapes according to VSEPR theory. So why it is called basic molecular shapes? Ini adalah kerana central atom hanya mempunyai bonding pairs sahaja around the central atom dan tiada kehadiran lone pairs, okay, on the central atom.
Since there are bonding pairs electrons only on the central atom, so the types of repulsion exist hanyalah bonding pairs repulsion. And that bonding pairs repulsion akan menyebabkan we get linear, trigonal planar, tetrahedral, trigonal bipyramidal and octahedral geometry or shapes untuk basic molecular shapes.
So to identify the geometry of the molecule, pertama sekali you have to draw the Lewis structure of the molecule and then identify A, which is the central atom, dan B sebagai bonding pair. Okay, so from the Lewis structure, awak kena identify berapakah bilangan bonding pair around the central atom. So actually we have another symbol iaitu E. So E adalah symbol for lone pairs electron. But in basic molecular shape, since kita tiada lone pairs, so kita takkan adalah symbol E in our formula of geometry. From the Lewis structure, awak akan identify bilangan of the bonding pair around the central atom. Sekiranya we have sebanyak 2 bonding pair, so the formula of the geometry will be AB2. So AB2, apakah nama of the molecular geometry? Namanya adalah linear. Okay, so nama lain untuk molecular geometry ni adalah electron pair geometry. So make sure if soalan give you any of these terms, you tahu nak refer kepada jawapan yang mana satu. Okay, so molecular geometry untuk AB2 adalah linear. Okay, so macam mana nak tahu bentuk linear tu, or how to draw bentuk linear? Okay, awak akan draw simply horizontal sedemikian lah. Okay, so for example, kita ada beryllium chloride. Okay, so dalam this structure of beryllium chloride, so when you are about to draw the linear structure, you akan susun ataupun lukis atoms dalam beryllium chloride ni dalam this orientation, dalam linear orientation. Alright, so the bond angle between bonding adalah sebanyak 180 degree. Okay, so ini adalah untuk AB2 iaitu linear structure. The other example will be carbon dioxide. Alright, next, if you find out kita ada sebanyak 3 bonding pairs around the central atom, so the formula geometry will be AB3 and the molecular geometry is called trigonal planar. So dalam trigonal planar ni kita ada satu central atom dan 3 bonding pairs. For example, BF3. Okay, so you akan susun BF3 ataupun F atom itu dalam kedudukan planar sedemikian, trigonal planar. Okay, dalam trigonal planar ni 3 bonding ini disusun dalam kedudukan di atas satah. Alright, so the bond angles between them adalah sebanyak 120 degree. Setiap bond angle, setiap sudut di antara ikatan adalah sebanyak 120 degree. So the other example adalah BCl3. And the next one will be 4 bonding pairs. So kalau kita ada sebanyak 4 bonding pairs on the central atom, so the formula of the geometry will be AB4. So for AB4, the geometry is called tetrahedral. So dalam struktur tetrahedral ini, dia tidak berada, 3 kaki di bawah ini tidak berada dalam kedudukan atas satah yang sama. Okay, tapi dia punya position sama seperti kaki bangku. Okay, so dia macam a bit mencapah. Alright, so dia tak flat di atas satah. Okay, seperti trigonal planar just now. So for example, kita ambil NH4+. Okay, so di sini awak akan nampak nitrogen central atom is surrounded by 4 bonding pairs. Okay, so bila ada 4 bonding pairs, maka you have to draw geometrinya adalah tetrahedral. And the bond angle between bonding adalah sebanyak 109.5 degree. Okay, setiap satu bond angle adalah 109.5 degree. So the other examples untuk tetrahedral will be CH4 and CCl4. Next, if we have 5 bonding pairs around the central atom, the formula of the geometry will be AB5 and the name of the geometry will be trigonal bipyramidal. So in trigonal bipyramidal, okay, you will draw 3 bonding pairs dalam kedudukan trigonal planar dan 2 bonding pair lagi atas dan bawah, which is dalam kedudukan linear. So that will give you trigonal bipyramidal. So in trigonal bipyramidal, for example in PCl5, the bond angle will be between the planar position, the bond angle will be 120. So ini adalah bond angle untuk kedudukan di dalam planar, trigonal planar. And between the linear and the trigonal planar, the bond angle will be 90 degree. Okay, so that is for trigonal bipyramidal. And the last one for 6 bonding pairs around the central atom, iaitu AB6. So for AB6, the geometry is called octahedral. So in octahedral, central atom akan terikat dengan 6 bonding pairs. So in this case, 6 bonding pairs itu akan disusun 4 bonding pairs dalam kedudukan di atas satah dan 2 bonding pairs lagi dalam kedudukan linear orientation. Okay, so for example in SF6, okay, so di sini bila awak nak tentukan bond angle di antara bonding, kita akan dapat sebanyak 90 degree. Okay, bond angle di antara bonding. Alright, so to get the geometry untuk setiap satu molekul, so again apa yang awak kena buat adalah draw Lewis structure untuk molekul tersebut, calculate the numbers of the bonding pairs, identify the formula of the geometry according to VSEPR, and identify the name of the geometry. And after that, lukis ataupun draw the structure of the geometry. And lastly, you can find the bond angle of the geometry. So that are the steps lah, okay, untuk kita nak dapatkan molecular geometry dan juga bond angle untuk sesuatu molekul. So just now we have discussed basic molecular geometry di mana central atom tidak mempunyai lone pair tetapi hanya mempunyai bonding pair sahaja. So how if the central atom has lone pairs also? How to find its molecular geometry kalau kita ada existence of the lone pair and bonding pair on the same central atom? So to answer this, we will discuss more in the tutorial class.